Drop 3 massive Earths into this violent, swirling vortex, and you would still have room to fit the moon. The Great Red Spot is an atmospheric leviathan, dominating Jupiter's southern hemisphere with winds tearing at 400 miles per hour. Since Giovanni Cassini first recorded a permanent spot in 1665, the storm has been regarded as an eternal fixture of our solar system. For over 3 centuries, the assumption has been that humanity was watching the same unchanging tempest. But the observational data tells a different story. In 2024, researchers auditing centuries of drawings found that the record is interrupted by a massive gap. From the early 1700s to the 1830s, the spot was completely absent. Cassini's original 17th century storm likely died during that century of silence. The raging system we see today was born later, in 1831, meaning we have been watching a much younger storm than we realized. Today, this modern storm is shrinking fast. Its current width is now almost identical to the size Cassini's original storm reached right before it vanished from the historical record. We are watching a planetary collapse repeat itself in real time. The Great Red Spot is fading. Because astronomers have observed this storm continuously since 1831, we have 190 years of data tracking its contraction. As it loses mass, its surface physics are mutating in ways that defy our standard understanding of anticyclones. In the 1970s, the Great Red Spot was a long, stretched-out oval. Today, it has shrunk into a much tighter, more aerodynamic circle, pulling its arms inward to conserve its spinning energy. But it isn't a smooth decline. Hubble data reveals that the entire system is physically throbbing, expanding and contracting its width on a 90-day cycle like a massive red bowl of gelatin. This structural wobble has never been identified in an anticyclone before. It suggests internal fluid dynamics that our current atmospheric models haven't been able to replicate. To find the cause of these surface mutations, scientists had to look beyond the cloud tops and investigate the storm's underlying structure. We have to dive past the swirling orange clouds and into the high-pressure darkness of Jupiter's lower atmosphere to see what is powering this engine. Measurements taken by the Voyager probes in 1979 established that the storm stretched roughly 170 kilometers deep into the atmosphere. Since that mission, the storm's width has plummeted, yet its 170-kilometer thickness has remained entirely unchanged. The vortex is shrinking horizontally while refusing to flatten out. Gravity measurements from the Juno spacecraft recently proved the roots reach even further, plunging 500 kilometers down into an abyss of metallic hydrogen. Maintaining a vortex that reaches this far into the interior requires an immense, continuous energy input. Despite these massive roots, the storm's surface level power is rapidly dissipating. There is currently no scientific consensus on why the collapse is happening, with multiple peer-reviewed theories competing to explain the storm's fate. One lead hypothesis suggests the storm is literally starving. For a massive anticyclone of this scale to maintain its mass, it must constantly cannibalize smaller, neighboring storms. Because Jupiter's regional climate has shifted over the last few decades, these feeder storms have become increasingly rare. Without them, the Great Red Spot is losing mass simply because it has nothing left to eat. A second theory argues the storm is not dying, but rather adjusting to survive in a new environment. The storm is bracketed by 2 opposite jet streams. If it shrinks enough to sit completely inside a single wind band, its geometry changes entirely. Once inside, the surrounding wind's kinetic force locks it in place, a planetary vice halting further shrinkage. Astronomers are now watching to see if the storm will bleed out into the void or successfully lock into this new permanent shape. Jupiter is a churning world of fluid dynamics and evolving physics. Its features are not permanent markers on a map, but active weather systems in a state of constant transition. The Great Red Spot is a complex, starving beast, pulsing like a heart as it approaches its ultimate stabilization point or its eventual disappearance. We are observing planetary evolution unfold in real time. This 190-year record gives us a front-row seat to a massive atmospheric shift occurring 400 million miles away. Take a moment to appreciate this cosmic window. In a few more decades, Jupiter's iconic face will look permanently different.